In this video, we will do an example in which we find the vector which is equivalent to the given directed line segment. Well, what you need to remember, is that any 2 point P and Q fixes you a directed line segment. We denote it by PQ. And then when you have any the directed line segment, you can make a vector which has exactly same direction and same length. It's called equivalent vector. And how do we do that? This is just by sliding your vector such that the starting point goes to the origin. If you do that thing, well, that sliding operation, you will get a vector which has exactly same direction and starts from the origin, and it has the same length. But how we do find the components of U algebraically? Well, that comes from the fact that if Q has component Q1, Q2, and P has P1, P2, the vector U, which is going to have two components, every component are made by subtracting the corresponding coordinate from the endpoint minus the starting point. So in other words, Q1 minus P1, Q is the endpoint minus the starting point, and the second component will be Q2 minus P2. And in the three-dimensional case, also you have the same kind of idea. The corresponding coordinates of end minus starting, end minus starting, end minus starting. Well, that's a very quick review of what we need to know here. In this case, well, the first component is the first coordinate of end point, here 2, minus first coordinate of the starting point, 1. The second component of the equivalent vector is the second coordinate of end minus the second coordinate of starting point. And well, this is 2 minus 1 is 1, negative 1 minus 0 is negative 1. And same thing here, but this time you have to do 3 components. Each component you find by the corresponding coordinate minus corresponding coordinate of end minus starting, end minus starting, end minus starting. And that is equal to negative 3. 2 and well, negative 1 minus negative 1, that is a good 0. And the last one, U, here is, again, we need 3 components. Corresponding coordinates of end minus starting, minus 1, minus 2, 3 minus negative 1, and 4 minus 0. And that gives us negative 3. 3 minus negative 1 is 4, and 4. Well, that's how you find a vector which is equivalent to the given directed line segment, end minus starting.